So the next experiment we will perform will be stepper motor control. Very simple experiment. Our objective here is to find few parameters. One is step angle and the second is number of steps per revolution. What is the function of a stepper motor? Stepper motor's function is it will move only in steps and it will rotate through a complete 360 degree rotation in certain number of steps. Now, where are the applications of your stepper motor is? Very simple application is your wristwatch, right? And then there are a lot of applications, say for example in robotics, you want to move an arm from one place to the other, right? So there you can use these stepper motors. There are three different types of stepper motor. First is permanent magnet stepper motor. Second is variable reluctance stepper motor. Third is hybrid stepper motors. What is permanent magnet stepper motor is? The rotor part of your permanent magnet stepper motor is a permanent magnet, right? And in variable reluctance stepper motor, the rotor part will move accordance to the reluctance value of your stator field EMF. And third is a hybrid stepper motor. It's a combination of both variable reluctance and permanent magnet stepper motor. In the sense, your rotor will be a permanent magnet and its rotation will be based on the variable reluctance EMF that you produce across your stators. So these are the three different types of stepper motors. Normally hybrid stepper motors are used if you want a very small step angle, right? You want to move, say for example 0.1 degrees, then you can go in for hybrid stepper motors. If you have your step angle close to say 10 degrees, 30 degrees, then you can go in for permanent magnet stepper motors. If you want 1 degree, 2 degrees movement, then you can go in for variable reluctance stepper motor. Now if you look at this particular setup, this setup mostly focuses towards the digital circuit of how to control the stepper motor. So this is the stepper motor that we are going to control. Now if you want to move your stepper motor position, then you have to give digital pulses. Now, so then you have to generate digital pulses also, right? So how do you generate a digital pulse? You will generate a digital pulse normally from clock pulses. Clock pulses is the only pulse where you have the square digital pulses. So the top portion that you see here, this is what is the clock generators. In this clock generator, we have provisions whether you want to provide a forward clock, you want to provide a reverse clock, you want to have a larger clock frequency. Larger clock frequency will result in what? The rotation of your speed will be faster. Lower clock frequency will result in the stepper motor rotating slower. So now if you look at this particular setup, initially this is a synchronous up counter, right? You must have studied about up counters and down counters, right? And this is a synchronous counter and this is a 4-bit counter. Why 4-bit counter? Because if you look at this particular setup, these are the 4 windings that you are having here. These 4 windings will be connected to something like this, right? So these are the 4 windings you can consider. One winding will be connected to say A, second winding will be connected to B, third winding will be connected to C, and fourth winding will be connected to D. Always A and B will be complement, C and D will also be complement. Meaning, if A is excited, then it will behave like a north pole, and when this is north pole, obviously B should be south pole, so it has to be a complemented form of your input. Similarly for C and D. Again let me explain you the working of this. If A is excited, then you are creating a north pole across your stator. So the permanent magnet that you have here will align itself such that south pole points this north pole. Then what you do is, you after exciting this A, you will excite this C. When you excite this C, this becomes north pole now. Now this magnet, south pole's permanent magnet rotor will get attracted towards the C. Now it will get aligned itself to C. Then what you do is you excite this B. When you excite this B, again the south pole will get aligned like this. Likewise, you change this pulses. So there are 4 windings. Each winding must be provided with 4 different sequence of pulses. Now how to do that is, you are going to use a 4-bit up counter or a down counter. Up counter when you are rotating your stepper motor in the forward direction. Down counter when you are trying to rotate your stepper motor in the reverse direction. Now how you should do is, this is the clock part, right? Connect your clock of your counter with the clock generator position. Very simple, right? Now mode. This mode will tell you whether to up count or down count. In terms of clocks, it will tell whether to drive in the forward direction or in the reverse direction. So you connect your mode here. When you connect your mode here, now we have connected our clock to our up counter or the synchronous counter. Now our objective is to drive a motor, right? So if you want to drive a motor, then it is something like a power amplifier. It has to be driven with a large frequency of large power in fact. In order to do that, what we have is, we have an output driver stage here. Let me maybe remove all these things for time being. We have a code converter. What is this code converter? Whatever is the synchronous positions, we will convert it into the code of based on how we want to excite these windings. So that is previously designed and filled inside this particular setup. So there is a code converter. There is no specific code converter. This code converter will convert the 4-bit sequential input from your up counter into the sequence in which you want to excite these windings. So how you will be exciting? First, say for example, A1 will be excited, A1 and A2 will be complementarily excited, and then B1 and B2 will be complementarily excited. So that is how this excitation is going to happen. You will see now. So what we do here is, so your code converter is done. Now this code converter's output will be fed to an output driver stage. You have to drive a large current to these windings. So that is what is the function of an output driver stage is. In fact, this output driver stage is fed to these transistors, the base of these transistors, to switch on these transistors, where the output collector of this transistor, they are all connected to your windings. Okay, and why do you have these diodes? They are nothing but the freewheeling diodes. You must have studied in power electronics what is the need for freewheeling diodes, right? So now let us perform the experiment. I have connected the code converter output driver stage into the driving transistor. So all you need to do is connect this parallelly. And there is nothing to observe here also. Okay. Now I connected. Now what about this particular part? You see some orange tag, right? If you want to control the stepper motor using your laptop or computer, then you have to connect it through a microprocessor. So there is a microprocessor port here. You can write programs and that will be connected. You can connect these driver inputs. All these driver inputs that you are having, you can connect it directly to these particular ports and you can write programs and then you can control. What is that particular program? Say for example, you want to rotate over 15 degrees in this direction and 12 degrees in the backward direction. You have to write. So if this keeps on moving, right? If there is a assembly line where you want to pick components and place, this is a repeated process. So this you can write a separate program and then you can give to the driving amplifier and then your stepper motor will rotate. Now let me switch on. I have switched on. Right? When I switch on, don't look at that particular part, look here. It is in the forward rotation. It is in the forward direction and speed is very low. So you see here that these codes are getting changed. These are complemented and anti-complementary. They will keep on switching based on the sequences that is required. You see at this stepper motor also. This is the stepper motor, you have it at the back, which is connected to this shaft. And the shaft has been connected to the pointer. You see, the one step that your pointer moves is called as the step angle. Okay. And what is the observation with this experiment? Before coming to the observation, let me play around with the other things. Now I am going to increase the speed. Look at this pointer, how fast it is going to rotate. When I am increasing the speed, I have increased the speed to maximum position. What is that I am really doing? I am increasing the frequency of this particular clock. You know what is a frequency is, right? So when I increase the frequency, the switching sequences are very fast. When the switching sequences are very fast, it is rotating faster. If I reverse it, again now it will be a down counter operation, and then it will rotate in the reverse direction. So this is what is the function. Now what is the observation, right? What is the observation that you must do is you must find out what is the number of steps that it takes to complete one revolution. You can assume that now it is going to cross 0. Again you have to start counting. You can have a stopwatch, you can use a stopwatch and then count number of steps that it takes to complete one revolution. So that will be noted. Once you know the number of steps it takes to complete one revolution, then you can find out what is the step angle. Normally step angle is represented by beta, and it is given as 360 degree divided by the number of steps it takes. If it, say for example, if it is taking 36 steps, if I increase the frequency, if it is taking 36 steps, then 360 degree by 36 will be equal to 10 degree. So 10 degree will be the step angle. So step angle is one important parameter that decides the stepper motor. So I'll put it on the reverse, I'll slow the speed, right? You can look what is the switching frequencies are. So this is about stepper motor. You use a laptop to play around with the stepper motors. So that's all about this experiment.